Welcome to today's discussion. We'll be exploring a research paper titled Help Steer to Preference, Complementing Ratings with Preferences, which delves into the world of reward models for aligning language models. The paper introduces a novel approach to combining different reward modeling paradigms. What are the key challenges in aligning language models, and how do reward models address them?
Aligning language models to follow instructions accurately and safely is crucial. Reward models play a vital role by assigning scores to responses, guiding the model towards generating higher scoring, more helpful, and safer outputs. A major challenge lies in determining the best way to train these reward models.
The paper mentions two popular paradigms for training reward models, Bradley-Terry style and regression style. What are the fundamental differences between these approaches, and why is a direct comparison difficult?
Bradley-Terry models focus on maximizing the reward difference between chosen and rejected responses to the same prompt. Regression models, on the other hand, predict a score, often a Likert scale, for each response individually. Direct comparison is challenging because these approaches require data collected in incompatible formats.
The authors address this data incompatibility issue. How do they overcome this limitation, and what is the significance of their contribution?
They release preference annotations for Bradley-Terry training to complement existing ratings or regression training within the HelpSTEER2 dataset. This allows for a head-to-head comparison of the two approaches using adequately matched data. The inclusion of human-written justifications further enhances data interpretability.
This is a significant contribution to the field. What were the findings of their head-to-head comparison of Bradley-Terry and regression models?
They found that both Bradley-Terry and regression models perform comfortably well when optimally formulated and trained on appropriately matched data. This suggests that the data collection method is less critical than ensuring the model adequately captures the information in the annotations.
That's interesting. The paper proposes a novel approach to combine both methods. Can you elaborate on this combined approach and its performance?
They propose combining Bradley-Terry and regression models, leveraging the complementary information in both datasets. A Llama-3.1-70B-Instruct model, trained using this combined approach, achieved a remarkable 94.1 score on reward bench, outperforming over 140 other reward models.
Impressive results. What are the practical implications of this combined approach, and how does it impact reinforcement learning from human feedback, RLHF?
This combined approach provides a more robust and accurate reward model, leading to improved performance in RLHF. It allows for better alignment of language models to follow instructions, resulting in more helpful and safer responses.
The paper also explores using preference justifications in reward model training. What were the findings of this exploration?
While using preference justifications directly proved less effective than using preference scores, incorporating multiple justifications per task improved performance, particularly in the chat-hard category of reward bench.
Can you explain the different evaluation metrics used in the paper and what insights they provide?
The paper uses reward bench, a benchmark with diverse tasks across various categories, to evaluate reward model performance. For aligned models, they use GPT-4, Turbo MT Bench, Alpaca Evil 2.0 length controlled, and Arena Hard to assess helpfulness.
The results show a clear advantage for online RLHF methods like PPO and reinforce over offline methods like DPO. Why is this the case?
Online methods, particularly reinforced with a leave one out baseline, offer more stable training and better reward maximization compared to PPO, which can suffer from bias and instability in its critic function.
How does the performance of the best model in this paper compare to existing state-of-the-art models?
Their best model, Scaled BT Expo, achieves competitive performance with top models like Skywork Reward Gemma 227B on reward bench, although it lags slightly in the chat-hard category, potentially due to differences in training data biases.
The paper discusses several aspects of different reward model types. Can you summarize the strengths and weaknesses of each approach in terms of accuracy, interpretability, and inference speed?
Bradley-Terry models generally offer the highest accuracy, but lack interpretability and calibrated scores. Regression models provide better interpretability and calibrated scores, while pairwise justifier models are most interpretable but less accurate. Inference speed is high for both regression and Bradley-Terry models.
Based on these strengths and weaknesses, what are the ideal application settings for each type of reward model?
Regression models are well suited for filtering SFT data. Bradley-Terry models excel in RLHF, and pairwise justifier models are best for human-in-the-loop evaluations, where explanations are valuable.
This discussion has been insightful. Thank you for explaining the key findings and implications of this research.